Welcome, fellow Kerbonauts, to a new episode of Kerbal Space Program Fully Loaded, the heavily modded KSP playthrough. Where we left off in the last episode was with a bunch of science, 86 to be precise, and now we are trying to decide which nodes to unlock with it. Sadly, all the nodes are now at 45 science, so we can only unlock one. We go for basic science because it allows us to unlock the thermometer, the magnetometer, and the procedural and stock batteries, which will come quite in handy when we start looking at using probe bodies. We are of course interested in the moon probe strategy, but we are a bit limited in our options right now because the administration building needs to be upgraded, which costs a ton of money. However, there's really no alternative if we would really like to do this moon probe strategy. For now, we're going to select another strategy first, which is local science. Local science costs a little bit of money, but it gives you more science for every science collection you do on the premises of the KSC, which is quite nice because that's the area we have at our disposal right now without building big rockets and spending tons of cash for, basically little probes that travel to different biomes, for which we have very little control right now since we do not actually have guidance for trajectories going back into the atmosphere, which is important if we need to land on specific points where we suspect other biomes to be. So what we instead do is collect the science nearby at the KSC. And you can see on the craft the science experiments now have little indicator lights which come from the mod indicator lights. And what makes it so nice is that it is providing a blinking green signal if there is new science to collect with this instrument at this location. And there are a few other color codings which are also helping along, but this is really helpful to actually notice when there's new science to be had. And you can see it here, it's blinking rather quickly since this is of course filmed with time acceleration, so that you and I don't get bored. So we are going to do this a few more times, and of course we are going to include traveling on the runway being its own biome. And we typically have 2 instruments of each kind here, not because it's very biblical, but because when you use an instrument you always have that residue science that you can bring back if you go to the place a second time, and you can actually skip going there a second time by bringing 2 instruments. And now we're kind of looking at local science too, which costs a lot of money, 20,000. We have 41,000, which means we would have to spend about 50% of our cash, and it was a hard decision to make, but in the end it was worth it because for the Moon Pro program we really need a lot of tech that is not available right now, for which we need a ton of science. And the other problem being, once you select a very specific program, you get a boost for milestones and achievements and collection of science, etc. for the biomes in question, but no longer for the biomes that were closer by or on different celestial bodies. So we do all the science that we can on the KSC now, because it's going to yield much less science later once we've activated the Moon Probe program. And of course we do not yet have the ability to EVA in flight while orbiting the Earth, so that is going to make a huge difference once we unlock it. But for now we had to choose which buildings to upgrade, and upgrading the administration building was more in line with the overall goal of proceeding towards the moon. So this must be almost close to the last science we collect. You can see we have quite a bounty of science now, and of course we unlock electricity first. Electricity houses at least the solar panels. We already have procedural batteries and normal batteries, but the solar panels are really worth our money. Since we are using probes, we are draining a lot of electricity during flight, even more so since we are using remote tech, which needs an active antenna to establish a signal back to the KSC. So we are unlocking not just the solar panels and another probe body, but also another antenna, which we're not going to use on next flight, but it's good to have, and we still have the money. And of course we need to unlock an engine that works better in vacuum, and that's the LV909 Terrier engine. There's also a Vulcan engine at our disposal, but we do not have yet any specific liquid hydrogen tanks, which will come later in the tech tree. So now we are selecting Moon Probe as our next central strategy, and this will give us a huge bonus on any science and any contracts that we do with probes, and it gives us some goals of orbiting the moon with probes, of impacting the moon with probes, etc., while diminishing other science on Earth. Now we need some contracts to really feed our fledgling space program. We collect a contract which requires us to test a Terrier engine on a suborbital trajectory, and we collect a contract that asks us to fly a satellite into a geosynchronous orbit, not a geostationary orbit, but a geosynchronous orbit. We also activated the strategy to boldly go to, which is an upgrade to an existing strategy we already had, which gives us a lot more cash once we return science from other celestial bodies. And here you can see the orbit of the satellite we are supposed to place into orbit for this company, and it is interestingly in a clockwise motion around the planet. A geostationary orbit would be in a counterclockwise motion, practically standing still over the territory that you achieve the orbit over, and this is of course totally different to what we've been asked. We've been asked to go into a geosynchronous orbit, which goes the other way around. So this is the construction of the actual satellite, and you can see it has a materials bay as per contract requirements. The same goes for goo canisters and thermometer and magnetometer, and there is this omnidirectional antenna on there, which looks a bit like something out of a hardware catalog. It really looks like a fork or something. Anyway, it's on there and it's going to be active all the time and providing us contact to the base station as long as it's in range. And we are going to use the second antenna, which you can see here above the solar panels, for more intermediate range communication with Earth. This is the battery. This is a procedural battery that I kind of fixed up to be in a conical shape with the magnetometer on top. And the stage is going to be driven by the LV909, which has a better ISP in vacuum. This is a logical choice for the upper stage. However, it is not able to create electricity. So the LV45, which we are using for the ascent stage, is able to create electricity when it is in use. The LV909 is not. So this is where the solar panels are really essential. This design of the rocket is also not the final design that you'll see in a minute on the launch pad, because I had to tweak it some more, take off some of the parts and put on some more solar panels, and also put on one more tank for the upper stage to give us a little more fuel to just be safe and get this mission over successfully. So now we are here starting our rocket, and as you've seen in the tracking station, the orbit needs to go to the west, and this is where we are headed. Actually, we might be headed on a straight line towards the west. However, we need to do a slight detour towards the equator, because of course Florida is far down south in the US, but it's not really at the equator. So what we need to do is to fly to the equator and then continue westwards and then match our inclination with the final orbit that we need to achieve. And something I really like about the many mods I've installed is this shine of the rocket firing on the ascent stage. It really, as you can see, it's rather something. And of course this is probe controlled, and you can see on the top left there's the remote tech bar with the green square that tells us that we have a connection with the KSC and that we are able to control this craft. And at some point we are going to have to switch the antenna we are currently using to another antenna that has a bit more range but also draws a lot more electricity. Also, this other antenna cannot be active right now because it would simply shear off due to aerodynamic forces. And now we've separated from our ascent stage, and using the LV909 stage to coast towards our new apoapsis, and we're going to go for something stable here first and then extend it outwards to where we need to go. And on the way up we can see that there's some more science to be had. The thermometer hasn't been up so high, so we can collect some science here in the upper atmosphere of the Earth and send it back to Kerbal. And as you can see, we still have this one contract of hauling this LV909 engine up into a suborbital trajectory. This is something we are going to achieve while we are flying towards our goal. And this is us now, since we are moving closer to the equator, we can now extend the apogee outwards and actually change our inclination as well. You can see it here. I'm not burning totally prograde, but I'm burning between the prograde marker and I cannot make it out here, but it should be the ascent marker or the descent marker, one of those, to fix our inclination to reflect what we need to achieve for this geosynchronous orbit. And we are pretty much, the apogee is pretty much where it needs to be. It's just a deviation of a few degrees in the inclination, which we are going to fix right here. And interestingly enough, the apogee is at 3000 kilometers and the perigee is almost 400 kilometers below. So that's not quite as circular as you would expect. So I'm not really sure this geosynchronous thing really works out for this, but as long as I fulfill the contract, I can call it, you know, whatever they like, as long as I get the cash and the reputation and the science. And of course, since we are now in a stable orbit, we can already look at some science that we can collect, and we can do the necessary preparations to ensure the longevity of this mission. You can see here the antenna that we'll use from now on for communication. So we are now selecting Earth in this window, and this antenna is now pointing towards Earth and it is active and the communication has been established. Now there's this thermometer still blinking, so this means we can send science off. And as you can see, of course, sending science consumes electricity, so it's vital that we are providing the craft with additional electricity, replenishing its reserves. And this means we need to angle the craft reliably towards the sun. We also have this magnetometer on board, which you can see extends rather nicely from the top here and gives us some more science. Not very much, but still a little. And since we have it on board anyway, we are doing the experiment and sending it back home to the KSC. And we can also, of course, retract the pole. And now it's time to angle us towards the sun. And of course, in regular KSP, this would be a futile exercise, since as soon as you start the acceleration, the time acceleration, the craft practically stands still. But for this to work, this craft has to autonomously, thank you, autonomously point towards the sun at all times. And this is where a mod called persistent rotation comes into play. You can see it here, and you can choose a celestial body to orient yourself towards and lock your rotation to this body. And this is what we've done here. Now these solar panels will point into the same direction relative to the sun, which is the important part. As long as we do not send any steering commands to the craft, it's going to point always towards the same spot on the horizon relative to the sun. And now, of course, we are coasting to the apogee, which, again, if you play with the Earth, then you can use apogee instead of apoapsis. And the same goes for the periapsis, which is, of course, the perigee. And there are going to be different terms for different celestial bodies, but for the moment, once we are around Earth, we are calling it perigee and apogee. And you can see now that the many different tracking stations, those colored dots on the Earth, are able to contact our craft since we are angling our antenna towards the Earth. And this is important. The farther out we are from the Earth, of course, we can see more tracking stations at the same time. If our orbit would be a lot closer to the Earth, then we would have less visibility because of the horizon, and this would mean that we might also get into trouble with only seeing one or less of the tracking stations. But the farther out we go, the less of a problem it becomes. And you can see here now my maneuver to extend the perigee to meet up with the expected perigee, and you can also see the apogee marker actually moving over the expected apogee marker, and now us waiting for us to reach the apogee and then spending a little bit of energy just to perfect the orbit as per specifications. In fact, I was pretty lucky here to do this on the first try and not having to burn into one of the directions on the nav ball to actually fix the orbit even more. It was a simple prograde retrograde burning exercise, except for fixing the inclination earlier on. So now we are expanding our perigee, and this is pretty much it. This is very close, and let's check the contract window. Of course, the LV909 contract is already fulfilled once we were in a suborbital flight at the proper height, and this is now the contract for the satellite, which we have now fulfilled since we spent 10 seconds in a stable orbit. Of course, this is nice, but there's also some more science to be had, and we didn't haul this equipment out here for nothing, so we are going to collect more science. And once again, you can see here the blinking of the indicator lights. Mods added blinking lights to any science equipment that was formerly stock. There's the possibility to add your own indicator lights to your rocket independent of any other equipment, but I haven't tried this out, but maybe in the future. So collecting lots of science is of course nice, but this satellite is also designed to be sort of a backup communication satellite once we need it. It has one more antenna on there, which we can use to aim, for instance, at the moon or at some other place, and it should provide us with backup capability to connect any craft to Kerbal, as long as it's in range, which is kind of limited with this antenna, but I think it will be sufficient to establish communications with any object within the range of, say, the moon. Yeah, so that's basically it for this episode. Regrettably, we're not collecting huge amount of science with this mission. We're going to have to send a probe to the moon, maybe with the science configuration we have here, which is not as bad. We still have 66 points to spend, which is not enough for any unlock, or at least not for any unlock that we are interested in. However, it's going to be sufficient to have us have a first shot towards the moon. And I hope you enjoyed this episode, and I'm looking forward to seeing you next time. Thank you and bye-bye.